All right, up next, we're going to hear from Rockfield Technology, showcasing how sensor-driven monitoring and engineering insight can significantly extend asset life. Please help me welcome Brent Lane, Resources and Heavy Industry Director.
Thanks, Tammy. Good afternoon, everyone. First, I just want to give a big shout out to the whole Osmine team for putting on such an incredible event. There's been some great sessions so far, and I'm looking forward to this afternoon. As mentioned, my name's Brent Lane. I am Rockfield's National Resources and Heavy Industry Director. And to put it succinctly, I'm here today to provide a framework for asset owners to extend the life of aged assets, which is a pretty up-and-coming topic as we start to get older mines. And that's going to be done through data-driven decisions underpinned by traditional engineering. So before I get into that, I think it's important to briefly explain who Rockfield are and why I'm in a position here to be able to talk to what this is today. So I won't go into all of this, there's a lot to cover in 7 minutes, but I want to harp on the purpose. So our purpose as a business is to maximise asset performance for a sustainable future. So put simply, extending the life of assets is in our DNA, it's what we do. So fast forward to what that looks like today in the resources sector. We're now 65 plus staff across Australia. We operate in multiple commodities. We have different locations there to service local channel partners and asset owners. And there's just a couple of our services that we offer across the resources sector. Now, all of this is to say, we've been around for a while, we're 26 years old, we've operated in different regions, different commodities, and across different assets. So the framework that I'm going to present today is asset agnostic and can be applied across different commodities, regions, and assets. So life extension of assets. I want to take a step back and look at how we traditionally manage assets today. So typically we look at time-based cadence inspections, visual inspections, and condition assessments. When assets start to get to the end of life, we typically fall back on the original design life that was engineered or Australian standards compliance checks. Now, what do these typically have in common is that they're fundamentally conservative in their approach, and they have limited real-time operational data. When you start looking at things in discrete elements, you miss any of the insights that happen between those inspection intervals. So as asset owners, where does this fail you? Well, I've been on multiple sites and unfortunately CapEx is constrained. It'd be great if we had all the money in the world to replace every aged asset, but it's just not the reality. So as asset owners, we don't have, I guess, the understanding or the data to understand what the criticality is of the assets so that we can prioritise where that money needs to be spent. Put simply, I like to think of the landscape as shown in the image here. We have a maintenance strategy that served us well for the past 20 years on the majority of our assets. But what happens as assets age is that their actual condition and their behaviour on site changes from what those fundamental assumptions were. And that creates what I call the strategy gap. And so I'm here today to present how we might be able to start to bridge that gap using data insights, analysis, and fundamentally underpinned by some of that traditional engineering. So what does that look like for Rockfield? So over the past 26 years, we've developed an end-to-end advisory service looking at just this. We've had a few learnings along the way. I guess sometimes market's not quite ready to adapt to where we're at, but we're in a place now where we're confident in the services that we provide. Starting at the left, I guess we're looking at the on-site assets themselves. Again, it's agnostic to the asset type. We design a system that installs sensors on that, depending on what you might need. That's all then ingested into our proprietary software, Macuto. Macuto is an analytics and visualization dashboard. And once you integrate that with your traditional engineering, what you can start to get is an action response as an asset owner. You can make informed, safe, and efficient decisions based on that. On the right is just a quick snip of one of the dashboards that we have for one of our customers in Australia. I have 7 minutes, so I can't go into every feature that the dashboard has, but come and see me afterwards. I'd be happy to give you a live demonstration. I want to walk through what each of these systems looks like in a little bit more detail. So starting at sensor installation, there was a big push when IoT first hit industry that everyone wanted data, and it was sort of to the point where it was data for the sake of data. So our engineers work closely with the end user to identify the actual needs And we have a suite of different gauges and softwares and hardwares that we can use for that. Anything from strain gauges, crackmometers, accelerometers to look at vibration levels, through to lower frequency monitoring of weather, like flood monitoring, for instance. The ingestion of that data then goes in, and I think Liam put it well when he said about the edge computing. We don't want to push enormous amounts of data to the cloud for the sake of it. We want to only push what we need to get the insights as end users. And we do that through any means of telecommunications that are available, whether it be 4G, 5G, or in remote instances in mining applications, sometimes we need to use satellite. The powerhouse of this whole system is the validation of the traditional engineering. We can get the on-site data, but without a fundamental model, analysis, calculations, we can't create a calibrated system so that you can draw insights from that. So underpinning all of these insights is the back-end engineering validation. Again, asset agnostic. We can develop FEA models, real-time fatigue models, crack growth propagation rates, and look at the real-time data on site so that you can draw those conclusions. So as an end user, what that looks like is a visualization platform that creates real-time alerting for a number of different applications there. So we're operating across different sectors and commodities, but looking at things like real-time stockpile heights, overloads of reclaim tunnels. We're looking at overload payloads in heavy haul trucks. So I guess the benefit of what we have is that because it was built from the ground up, we can suit it to tailor the needs of our clients as required. I am running out of time, but I do want to just finish on what this looks like in industry. It's always well and good to sell a framework, but to see it in action sort of just ties a pretty bow around it. So just a couple of years ago, Rockfield were engaged for a 20-year-old train loadout bin in the Pilbara region. Maintenance had changed one of the design aspects to be more maintainable from another engineering company. It was under-designed because the assumptions were wrong, and what we ended up seeing was M24 bolts started popping. For any engineers in the room, you know the loads to pop an M24 bolt are extreme, and so understandably sites started stressing out about that. We were engaged to go to site to start installing strain gauges and accelerometers across the bin to understand what was actually happening. We were then engaged for short-term remedial advice, and that was done using a multitude of different technologies there, so motion amplification, strain gauging, DEM, to build into an FEA model that was calibrated to what it was actually seeing on site. And I am running out of time, but the last thing I just want to note is we continued monitoring for 5 years, and what we started being able to identify was operational trends. The bottom image there shows the remnant life, so real-time fatigue monitoring of this asset, and you can see the spike that occurred. The operator got an alert, we called them, had a meeting with them, and it turns out they'd actually changed an operating set for the minimum amount of material that was allowed in that bin. I guess without this insights, they wouldn't have known that that was going to have a detrimental effect to their fatigue life. As a result of this, they changed it back to the original settings, and it plateaued again, knowing that they had, I guess, longer life for the bin. And ultimately, they've delayed capital expenditure of a new bin by 5 years as a result of this system. Looking forward to catching up on the rest of the sessions today, but if you see me around and have any questions, please feel free to come and say hello and ask me anything that you want about the system. Thank you.